system data. Okay, it's the name for this session. It's really about using all the type of data that just log files, trying to expand the scopus of learning analytics. So we will start with Benedict. Please.
All right, good afternoon, everyone. My name is Benedict. I'm from the National University of Singapore. Together with my counterpart, Manolis Mavrikis, we have actually come up with a research paper on eye fixation patterns using online learning tools, systems. Right. For this particular paper itself, we are going into different kinds of online learning systems that actually simulates learning, and in more particularly on eye tracking technology to monitor eye fixations when the students are doing the online tutorials. Our findings actually looked into visualization of scanning behaviors, and in the end we noticed that their scanning behaviors actually fall into three kinds of eye fixation patterns. From the eye fixation patterns alone, we'll be able to go and see whether or not these patterns actually correspond to different types of academic performance. Strangely enough, altogether we have 6 patterns, and of the 6 patterns, they do correspond to certain forms of academic performance, as you will see soon. Right, a little bit on the background. I actually have the privilege to have this research experiment done on pre-university students, which is aging about 16 to 18 years old. Pre-university means that there is actually a 2 to 3 years of education before they enter university. And there are two kinds of education. The one that I'm actually looking into is a technical education where they are learning engineering, programming, and sciences. So when we talk about pre-university students in Singapore, we do go into education in terms of technical aspect, and the pre-university institution that I've actually gone into for the research experiment is more on programming. Now, students are actually doing a lot more on learning how to do programming, not only through lectures and tutorials and practicals, but now there's actually a rising usage of online practical tools such as Udemy, such as Codecademy, such as Codecademy. And many times the teachers, the educators themselves find that it's actually quite beneficial because in a way they have visibility of the students as they do on engaging students on online assessments. They're also able to go and look into how students perform on real time, and as well as in real-time feedback to the teachers to see whether or not the students are able to go and cope with the task at hand. From the students' perspective, there are forms of collaborative functions on these platforms. They can communicate, they can talk, they can also do some form of peer assessments, timely feedback for them as well, to know where are the points where they need to go and improve, what are the things that they have done correctly, what are the things that they have run wrongly, as well as some form of interactive engagement compared to tools that are static. So, in a sense, there is actually advantage from both educators as well as for students using online tutorials. Now, the tutorials I'm talking about today is actually more on how they are able to go and learn programming tools. This is the setting for the labs in Singapore. The students are third-year students. The third-year students are coming in from education such as learning how to do software programming, so more to computer science. And a lot of times, yes, teaching and learning using online learning tools has been beneficial, but there are some cases where they are going to use just the online learning tools without any idea of whether or not the students do have any engagement in cognitive activities or any sense that they've actually learned anything from the online tools. Basically, because the online learning tools do capture whether or not they completed the task, the amount of time they completed the task, and basically some of the other basic functions of whether or not how they progress through the series of tasks. But they have not been able to go and annotate if the students do learn anything or whether or not they learn anything new. So there might be cases where the UI of the online learning tool itself might not be encouraging and may not be encouraging in terms of cognitive activities, or if it's encouraging, the UI instructional designers might not be sure whether or not they're doing the right thing, or they're not helping the students at all. So this particular research is to find out whether or not the online learning tool itself, which aspect of it is actually helping the students, which aspect is not helping the students in terms of cognitive activity and learning outcome. Right. A bit more on the background. For eye fixation, there are many kinds of research that has already been done, and a lot of times that we are asking whether or not, why are we doing this? Basically because individual differences among the students. I mean, individual differences, I'm not talking about the capability or the ability of the students, but rather the differences in terms of approach to learning. Now, individual approach to learning are somehow different among students, and because of that, there's actually a variance in the learning outcome. The learning outcome most of us educators are looking at is the performance of the students, the GPA result, or whether or not the students are capable of being able to go and learn new tools, new ways of developing solutions, software solutions. So therefore, there's a need to address this diversity of student learning approaches. We shall see later what I mean by different learning approaches. It's quite evident when it comes to approaches when you're using eye fixation pattern tracking. So in terms of eye fixation pattern tracking, there is a few methods of recording or measurements. Some have used fixations, meaning the locations where the eye is fixed on screen. Saccades, where the eyes move from one fixed point to another fixed point. Dwell time percentage means the amount of time that a person looks at a particular or focus on a particular point on the screen. Pupil diameters and blink rate. Now, the reason why I highlighted the first three and not the last two is because for this particular software, or rather hardware I'm using iTribe. iTribe is an eye scanning tool which will be able to go and record down where the user or a learner actually looking at as they're actually doing the online tutorials. We are able to go and record down because it is up to 60 records per second. The fixation of the students themselves, where they move from, the saccades, as well as how long, the percentage of time that they have spent on a particular area on screen. Apparently, from these records, we are able to also see that somehow different patterns actually bring about some relations to the different students' academic performance. For this experiment, we actually use Codecademy. Codecademy online tutorials actually offer a few range of programming tools, like say for PHP, they also do on JavaScript. These are C#. So these are the things that are offered online. Students are able to go and learn really fresh online. As I say, they are not even experienced in PHP. They go on the tutorials on PHP. They learn from scratch, from start all the way until, I believe this one altogether there were 13 tutorials. When they finish the 13 tutorials, they were basically able to go and code in PHP. The UIs for the entire spectrum of software development is also similar. It's broken down into 5 main blocks. A on the leftmost here, leftmost top corner. It's introduction. Introduce the topic of the task, of the instructions for the task, followed by B, and C is hints. Now this one is important because for the hints alone, they do not show the entire solution yet, but it requires the students to click. For D, it will be where they put in the solutions, and of course programming output will be E, where they have a bit more feedback of what they have done. If they encounter an error, there won't be any output in E, but there will be just an error message that is shown below here. Right. The setup will be as such where students are given either laptop or desktops. As you can see here, very center there will be a bar. This piece of hardware, which is called the iTribe scanner I mentioned earlier, is actually linked out to a laptop for this particular research, but it can also be linked out to desktops. Now, at the start of the semester, when the students come in and they were told that actually yes, they will be monitored, but of course this one is for ethics issue. But for cases where I'm going to monitor the way they actually learn from online learning tools, I'll be taking from random examples that they have actually done across the 3 months when they are doing their final year project. So these students are actually doing their final project in the lab. Just now I've shown you all. Because of this experiment and because of this setup, it's very close to natural observation. The reason why I'm doing this is also because if I'm going to tell them straight that I'm going to monitor you, how you're going to learn, and they'll be so conscious about it, in the end, the data itself might be biased, right? So I would tell them at the very start of the semester, but throughout the whole semester, I will be capturing data randomly. All right. So just now I mentioned all in all, I have altogether six data types, six plot types, I would say. All right. The first one, let's call it plot type FP1. FP stands for fixation plots. Some of the students, when they are going about doing their online tutorial, a lot of them have consistent distribution. Some of them have consistent distribution of fixation across all the blocks, from instruction all the way to hints, all the way to editing and output. Now, this one, bear in mind that this one did not take into account the sequence of how they look at the screen. So which means to say that these students might look at the hints and then after that they will look into the instruction and it might go around. But then again, this particular capturing of the data does not take into account sequence. The next part will be on sequencing. Right. So from here, we notice that there are some students do look into all sections of the user interface. For this particular case, why is it that students actually are able to go and come up with a solution but still have a lot of fixation plots on hints, might actually suggest that the students themselves are either they have a bit of a misconception, which means to say that they have actually read the instruction, the introduction, they have done some work, they have tried, but unfortunately they're not able to go and get a solution, and so they have tried to see some of the hints that are being provided. And the hints that are being provided by Codecademy can go all the way into giving you the solution, the full solution itself. So there are students that are having misconceptions. They tried, they're not able to go and code, they're not given the correct solution, and so they will look into the hints and then continue. Now bear in mind that Codecademy will not allow you to go and proceed if you do not give the correct answer. So in either way, you will be able to go and capture if a student do have any misconception. Another school of thought will be also the students are more, they are not confident enough, which means to say that they do not want to go and put down their solution, although they might know it. So they will look into the hints, they'll get the full solution before they proceed. Now, this is interesting, where there is another group of students who have never even looked at the instructions, never looked at the introduction. They go straight to the hints and they go straight to the solutions. Now, the thing about online solutions or online learning tools are that, well, these things won't be captured if you do not have an eye tracker device. So most of us educators will say, all right, so you got a full solution, you did it in 5 minutes, for the rest of the class was still struggling for the hour, and so you get the full score. But many times the students are actually what we call cheating themselves, and many times also the lecturers or the educators themselves might be clueless as to whether or not the students do learn anything at the end of the day. These are the students that go all the way to the solution from the hints, without any respect for learning in that order. So in a way, these students, either they already know the solutions or they do not care to learn at all. The third kind of fixation plots is one that do not have any plot, or rather very minimal plots on hints. So they look into introduction, they look into the instruction, they come out with the solution, and of course they check whether or not the output will be one that is that allows them to proceed further. Now these students, they comprehensively looked into the instruction and managed to go and come out with the solutions through the instruction. Later we will see whether or not which group of students actually score well in the GPA and also in the project average. All right, I'll explain project average a while later. Right. So if you recall, just now I mentioned that the first type of plots do not take into account sequencing. Now, the next three plots, which are what we call as scan plots. Now, scan plots take into account sequencing, which means that we'll see whether or not how the students actually scan from one point to another, as well as how long they stay on one point. So that take into consideration the sequence as well, the circuits as well as the dwell time. Now, there are research that has been done for students that are reading texts. That means not doing programming, not doing online tutorial, but they are reading texts, meaning case studies, texts, or maybe reports. And these case study texts or reports, they do have certain classification of students having annotated as slow linear readers. So I took that same approach and see whether or not can I annotate learners that are on online learning tools and see whether or not do they also exhibit the same kind of behavior. And apparently they do. So there are a group of students that do exhibit slow linear readers, where what do? They go through from introduction to instructions in that order, but at a very slow pace, and they do a lot of rechecks before they go into editing, and then they go into output. So the next scan plot, which I name it as SP2, now what do? They follow similarly to what SP1 is doing, but at a faster pace. So they do very little rechecks. They go through linearly from instructions, from introductions to instructions, and then go through editing at a very fast pace. The last one will be one where we have a lot of lookbacks. Now, what are lookbacks? Lookbacks are students who read the introduction, the instruction, go into the text, go into the codes, do their codes, and will always return back to the main points. The main points of what the instruction is about, do some rechecks before they proceed. So these are the students who want to go and associate what kind of codes are done or are produced by themselves and see whether or not they do have any association with the learning outcome or from the instructions. So these are what we call as learners that exhibit topic structure readers, the similar form of eye fixation. Right, so all in all, we have data from these 6 categories. And these 6 categories are annotated by independent reviewers. And we want to see now whether or not from these 6 types of behaviors, how are they associated or related to 2 forms of learning outcome. The first one being GPA, and the second one being project average. Now, when I talk about GPA, it's all the modules considered all the modules that they have taken from their first year and from their second year. Bear in mind, these are final year students, third year students. They are going to do their final year project. So basically, they do have a GPA grading of all the modules that they've already taken for the past 2 years. Another school of thought will be some students are, academically intelligent, but they are not very skewed towards practical development. Meaning to say that they are theory very strong, but when it comes to coding, when it comes to debugging, they are practically clueless as to how to proceed. So I decided also to come out with a finding whether or not these 6 types of plots do have any relation with project average. What are project average? Every semester they would have a major project. All right, may it be C++ project, Java projects, but every semester they will have a focused major project, programming, practical in that sense. And so we'll see whether or not do they exhibit some form of relationship between the average of their project score and, of course, among these 6 plots. So here it goes. Right. So if you remember, for what I mentioned just now for FP3, these are students that exhibit comprehensive reading of the text. In this case, instructions, in this case, introduction, and somehow they actually absorb the fundamentals of the instructions themselves. So apparently, FP3 do have very high standardized coefficient values, which means to say that there is very strong relationship between FP3 and student project average score. Apparently, the other side of the spectrum, FP1, we would have students with the lowest standardized coefficient values. Now, what are FP1s? FP1s apparently are not the students that go straight to the hints. No, they are the students that laboriously go through the introduction, the instruction, try to come out with a solution, fail to come out with a solution, go through the hints, got a solution, and proceed. Now this means that they managed to finish the task, but apparently the misconception which they have in their heads still stays with them. So they might be able to go and proceed with the task, but they might not be able to learn anything. So what they do is that they have just copied our answers from the hints and proceed. They are, of course, what we call as hardworking students, but unfortunately, because of the method or their approach of learning, they will not be able to go and grasp what is the fundamental of this particular learning task. Well, we switch to a little bit more general form of grading, which is the GPA. That includes both the project scores as well as their theoretical other academic module scores. And true enough, FP3, which is the students that would learn the fundamentals of the instructions, the gist of the whole task before proceeding, they are also the ones that actually score the highest in GPA, and they are the ones that actually have a strong relationship with FP3. And FP1 are those students who have retained misconceptions and may not be able to go and understand really the fundamental underlying theories behind what they have learned, and they are also the ones that are having the lowest in terms of standardized coefficient. But apparently, there are also p-value which is statistically insignificant. Now, what does it mean? It means that there are also cases where students do exhibit FP1, but because there are cases where in academic terms you can memorize, is what we call rote learning. You can memorize your solution in examination and regurgitate out, and so their scores in their GPA might not be a reflection of their understanding of the topic at hand. Going forward, when we look into the scan plots and project average, we also see that there is a strong relationship between SP3 and project average. Now, what's SP3? SP3 are students who have lots of lookbacks. Lookbacks when they do development, they do one or two lines or 3 lines, and then after that they finish one section, they will look back and see whether or not have they accomplished what is required for the task, or they might also check, confirm, and see whether or not these are the things that they can learn or they should learn in terms of learning outcome from the task that's given. So students that exhibit a lot of lookbacks happen to be the students that are also scoring very high in terms of their project average. And for SP1, SP1s are those that are slow linear readers, they follow the instructions, they follow the instruction linearly all the way, but somehow they are not being able to go and, they may not be able to go and comprehend what is the instruction, but still they laboriously continue forward. So in this case, it suggests that because of this weak association with project performance, the students might not be able to go and understand how to do programming without having much look backs. Sometimes when we say that you don't learn anything unless you use it or you do it in practical. Similarly, the students that are done in practicals, they have done the programming, they have then looked back and see whether or not they have done it correctly. These are the students that would be able to go and absorb and retain knowledge. But for students who go through linearly, there are students who are not able to absorb the knowledge or retain knowledge. The last one that we are looking into was the scan plots and the GPA, and the similar results will be the SP3 do have the higher standardized coefficient, which means they have strong relationship with the GPA performance. And similarly for SP1, it is significant. It's not significant enough for students with year 2 GPA performance. All right, to wrap it up, this one is very much on the surface, I must say. That is only the tip of the iceberg, because in a way we have discussed also our team, and there is for sure not just these sets of patterns. There are many patterns that are also in transient or maybe variation of patterns that are yet to be discovered. But from this experiment alone, we'll be able to see and understand that they do have some form of strong relations among different types of eye fixation measurements. And from these measurements, we also are able to go and have some form of relation with the engagement of learning and the type of learners. The type of learners meaning how they approach learning. So the results suggest that the students actually different types of scanning behaviors do have some form of achievements in terms of their GPA or project grades. Thus, to conclude, a lot of times that we have actually introduced online learning, many times that we have thought that, all right, we have actually embraced emerging technology and that might be very good for the students, but many times these surrogated tools might not really benefit the students and might hide some of the facts where the students are able to go and complete the task, but they do not really understand what they are doing. So if we want to go and understand how the students are approaching such learning tools, perhaps eye fixation patterns might be able to go and tell us whether or not the students are engaged in cognitive activities, or if they are not, how are the levels of engagement do they belong to. Now, the characterizations of the different types of learners will also be able to go and tell us different, although as of now, as I speak, it's only 3 different types of eye fixation patterns. I believe there will be many more. And the data which corresponds to these eye fixation patterns will thus actually show some form of relationship with the performance of the students in other academic modules as well. So to conclude, the method of research of analyzing eye fixation patterns can actually identify different types of learners with respect to their cognitive activities as well as academic performance. Thank you.
No, it's okay. I think.
Okay. This is Xiaofu from University of Hong Kong.
Right. For the benefit of those who are sitting behind, the question was whether or not for these fixation plots, how do we annotate whether or not it's FP1, FP2, FP3? Now, I mentioned earlier that these plots were actually generated. I have somehow missed out the point that actually the visualization tools that we are using was Tableau. And from here, we actually came out with these 3 plots. Right. Now, the annotation for these are pretty much on the independent reviewers. I mentioned there are 3 of us. And from here, we actually annotate FP1, FP2, FP3 according to whether or not the consistency of the distribution. As for the first one. As for the number of counts, that they are actually more focused on the hints. And the last one will be more on those that have no fixation at all, or very little fixation on the hints. So it's all done pretty much manually because for Tableau it's more on visualization tools, but from here it's quite evident as to where the students belong, which category the students belong to. As for your second question on how are we going to annotate students who fall halfway in between one or the other, and that there were some cases where the reviewers were actually should I say arguing? Yeah, okay. They were not really in agreement whether or not the students fall under FP1, FP2, FP3. Now, that's why I mentioned at the end of my presentation, there might be also other patterns that we are looking into. So we are not really strictly looking into FP1, FP2, FP3 for that matter, but there are many others. So this one is actually quite a preliminary stage of our research work.
Related to that,
Sure.
does it work now? Okay. How many students did you have? How many students did you have, and how many fell into each pattern? Do you have?
Right. All in all, I have 61 students. Then what was the second question?
How many fell into each pattern? Were they?
All right. Altogether, there are 61 students, and then the students, they are using this tool to go and develop on PHP. PHP on Codecademy, we have 13 tutorials. So the 13 tutorials, the students that are in majority that falls under FP1, FP2, FP3, well, basically they spread across quite fairly, right?
And what about if you say they go over 13 modules,
Right.
do you see that they change their like if they're in pattern 1 in the first, because maybe they know that they can program a little bit, but when it gets more difficult, that they change patterns?
Yeah, yeah, I know what you're saying, but apparently the students that their approach to learning, they're very consistent. So for those students who go straight to hints, for example, they exhibit the same thing across. Perhaps maybe the first time they were a little bit more conscious about their action, but once they discover that there was a holy grail on hints, they fix on it. It's like, yeah, they practically fix on it. And there are students who, I mean, they just avoid hints like poison. In a way, there are cases where I would think that the students might, ask their peers and may not be able to go and record down on our system. That might be a little bit more on the shortcoming of the system, but still we'll be able to go and capture to see whether or not they do look at the hints or not through the clicks. Yes.
In a study that we were running with Ulrich, we discovered that we have a dependence between the structure of the learning activities that the students had to follow, like the length of the activities that they had to do, and the number of times that they were going back and forward. So I don't know to what extent in your studies you were taking into account how the activities were scheduled and whether it was the same approach in all the modules that you were studying.
For the 13 modules on PHP, they are able to jump around, but in the fact that they jump around because I do also do camera capture. That means I will also see whether or not they are jumping around, and so we do have to go and it's a difficult process, but we do have to go and capture and see whether or not they finished off one particular exercise, and from there we capture the entire eye tracking pattern for that exercise. we do not take into consideration whether or not they have done the difficult ones first or the easier ones first. This one is more to the scope of our research, more to the approach to learning, whether or not it's difficult or whether it's easy. That one was not one of our index.
Yeah, but we were not measuring to understand it was easy or not. It was like somehow if the activity was too long, for the students it was somehow more difficult to follow it. So they need to, okay, let's try to recall what was going on here in this specific topic. So it required them more a fact of reviewing what was before.
Right. For Codecademy, for this PHP modules, it took no more than 5 minutes. It's very simplified. It's more to teaching them how to go and code different functions rather than teaching them to remember things. Yes. Welcome.
Hi, thanks. I just wondered to what degree did time play a role here? Within each of those types, was there any differences in times? Like, were people fast to go to the hints because they were just getting the job done as efficiently as possible, or were they genuinely dwelling? And then, you know, did you notice that within the types that you labeled?
Yes, yes. So I have actually considered the timing factor here, where, well, students are actually going into very deep into looking at the instructions and have yet to even start to do their programming. And when they start to do their programming, they might not get the right answer, or if they got the right answer, whether or not what is their next form of action. That one I took into consideration in terms of timing, in terms of sequence and timing.
Okay, and just as another one, you from one of the first slides, you didn't talk about the pupil diameter or the blink rate. Were they considered at all as useful in this exercise?
Sorry, I didn't get that.
Did you, in the first slide, you had pupil diameter and blink rate, but did you not consider them important in this exercise?
Ah, I see. It might be important, but unfortunately, due to the constraint of the tool that I'm using, there are many cases where experiments done on eye fixation will require bulky and somewhat uncomfortable tools, which means to say that it's either an eyewear or perhaps maybe positioning the students where it's not natural for them during learning of coding. So what I decided to do is that I decided to come up with some form of naturalistic environment where the students themselves are already there in the lab. The only thing that is additional for the setup compared to a normal lab would be that that toolbar over there. It's not really a toolbar. It's actually a hardware for scanning of eye fixations. So I believe it was after the first week, none of them actually asked me about it anymore. So it was always there, it's always on, and from there I believe that I actually capture data in the most natural way.
Thank you.
Thank you.
Thank you, Benedict.
Thank you.